Yeah, I got it back. So I got it yesterday. That's why I haven't put it. But it's people can see is this one is for the Raspberry Pi, because when we're doing the machine learning on the Raspberry Pi just for the CPU, it's very slow. Um, so this device is from Hilo. So it's this guy, which I can connect directly. But the problem, the problem that I mean that I'm hitting is I can connect this directly to the Raspberry Pi 5, but then the storage I'll be using will be the SD card, right? So that's why I got this one, because this one is 256 gigs, and then on the second one, supposedly what I found online was I can take out the AI module and then put it on this one, and then I will have like the NVMe storage to save all the models. The models are very big to download from Hugging Face or wherever you get them. Um, so that will put them in the NVMe. And I think that's what we're going to talk today about. Like, once you download the models, how do you make the models available in a container and in Kubernetes? Any questions?
Yeah, so just to for me to understand, so you have a Raspberry Pi. On the Raspberry Pi, you're going to attach that module which you have got, which is AI enabled, right?
Yeah,
And that is this is what you're going to attach to the Raspberry Pi. Okay.
yeah. This is
Uh,
not. I think it's not a GPU. I think they call it a module.
okay.
I think it's TPU. Let me see. They call like generic names called accelerator. It's a Halo 8L AI accelerator. I'm guessing that it's the same thing like TPU, the same way as Sergio showed last time. He was showing the Coral TPU, and he was able to
Mm-hmm.
do the cla- classification, AI classification
Mm-hmm.
uh, with that. So the floating point operations, right, will be faster on that module. So I'm hoping like this will work the same way, and it's a matter of like the software um,
Okay.
that typically people use for talking to GPUs through the software or the containers, right, will be like compatible with CUDA, and then that's how they use Nvidia. But in this case, this is not CUDA, so this will be using just whatever library are available for Linux that I will be
Mm-hmm.
installing, right, a driver, and
Okay.
it will act as a device, and it will not use CUDA. So that's
But on
that's
the
so far what I have learned about Nvidia
okay.
and GPUs.
But on the Jetson, the one other you have a complete GPU attached to it, right? That is
Yeah, it's a complete GPU. It's not on the what I read. It's not on the PCI. So it doesn't work. It doesn't work like the devices like NVMe. There's a tool, NVMe SI, that everybody uses to query the GPUs. It works if it's a regular like um, GPU, like a PCIe card. Like if you buy a computer for gaming at home, and
mm-hmm.
you install a PCIe card and install it, then you can use it will use CUDA. Both use CUDA. But normally you will find the driver isn't, but the way you talk to it it's a little bit different. So that's
Mm-hmm.
why in the Jetson I can move to that part. It was kind of tricky to get it working. Um, so for example, let me hide this. In the Jetson, I found, and I've been documenting the things in my repo here. So I deleted all the stuff about CUDA that I was doing. So this is the instructions like um, from CUDA natively, like in the host operating system. When you flash the Ubuntu on this machine, then it would use it has the driver and then CUDA works out of the box. So running something like this NVCC dash version, it will give you like it's using the uh, CUDA information. If you download this repo called Nvidia CUDA samples and you compile it, device query is what would you use. I think I covered this last week. Then this would work. Um, if you try to run it from a container, that's what I did, and that's what I'm going to show that it wasn't working. So to get like a container, Docker container, to talk to the GPUs, you have to do multiple things, and I showed last week some of them. But the best way to get it is this amazing repository called Jetson Containers. I don't know how many stars it has 2,000 stars, and it's JSON Containers basically has all the like tricks and hacks and workarounds to make the normal software that runs on normal servers with Nvidia work out of the box. They don't work on Jetson. So he has he said, hey, I'm in the person, or maybe this is a community project. Um, this project has like machine learning on Jetson and Jetpack. So Jetpack is kind of like the software that gets installed with Ubuntu when you flash the device on these Jetson boards. The one that I have is the NX or Ring NX, so it's 16 gigs, and I showed the spec last week, so you can look at that episode. But yeah, if you want to run, I think last week I was trying to run PyTorch out of the box, right? Doing a pip install, trying to get a base CUDA image, and then putting PyTorch, and it wasn't working. So this repo figure out all these packages. So if you just want to have the CUDA, just CUDA by itself, it's here. If you want Python CUDA, is here. If you want LLM, and that's what I'm going to show, or Llama, it works out of the box. So I can let's test the CUDA. So for CUDA, even RAG, like there's cool examples in here that he has of like out of the box. This container will have an example of using a machine learning model. This one is Java, JAVA. This is the one that it does vision recognition. So you can drop an image here and then ask the model, and I think he's doing it with voice. So in the microphone, he's speaking the text to send to the model, and it's saying, what kind of fruits do you see? And then the model would analyze the image and give you the results. Or if you just want to speak, right, not talk about this one uses the I got it down because I speak Spanish, but I think everybody goes Llama. Llama 2, the 70B, and this one is on Jetson AGX. So you need a little bit more. This one has more memory, a little bit more powerful. But I was able to get other Llama, even Llama 3.1 running on my Jetson. I'll show that in a minute. But yeah, if you have one of these Jetson devices, these are cool. This is the repo to use to run containers with the machine learning, and also use it as base images when you want to run them in Kubernetes or just plain Docker. Yeah, this one is video recognition, so it's recognizing the face, the person. So this one is using a different model. This one is the same thing. The Java one, and it's live, like streaming the frames of the picture. Right? It's with his finger, he's saying a 1 and a 2, and the model quickly giving you the answer on that. Yeah, we can try some of this if people want to practice, but let's start with the simple one. So the simple one that it doesn't work, that wasn't working for me, was CUDA and PyTorch. So if you go to packages, you will see all of them that are here, and then you will go to CUDA, and then different ways of running CUDA. And then this is the Docker file. So he figured out how to, so this is the Docker file, and then like everything related to that, and then the samples which has the device query that I was trying to run out of the box. So let's try that one. So if you go to CUDA, you will see the different images that he has. So he has the CUDA 12.2 that I was trying the other day and it wasn't working. So now I can just get an image that he already built or build it. Like um, you can run it. Let me see. The other thing I wanted to show was to set it up. I was missing one tiny thing. So I did the setup, and for the setup, basically you clone this repo and then you install it. And this basically creates a Jetson containers script in user bin. And then it also creates something called auto tag that will figure out what is the image for your version of Jetpack and GPU to use. But this is the piece that was missing. I did this in the daemon in the docker.json and also in the containerd, but in this one is I only did this portion of like adding the runtime NVIDIA and then the path to use the NVIDIA container runtime. And I did it with the toolkit, and the toolkit actually
Hi,
modifies.
Carlos. I
Go
have a
ahead.
question here. Did you used any specific version of CUDA? Because when you were mentioning in your Jetson,
So yeah, you have to use a CUDA version that is compatible with your driver. So that's why you need to be
yeah.
aware.
So in this Jetson, what exactly you have used?
So yeah, so the one that I need to use if I go and I run, let me see, if I run device query, right? I have the driver 12.2. So I have tried like
Yeah,
things with
yeah,
CUDA 11 and it didn't work. So I need to use at least CUDA 12.2.
yeah. So it's a big challenge one.
What's the challenge?
Yeah, because if we are not very specifically, in my earlier experience, like whatever the specific driver we are into it, all our exercise should be related to that. This was my experience with CUDA.
Yeah. So the driver needs to match, like
Yeah, the device what we are.
the container
Yeah,
has a library, and then the library uses the driver. So a lot of people where they have problems is when they have given software or they have environments where those two things are not
yeah, yeah,
compatible. That's what you mean, right?
yeah, yeah. That's what I mean. Like
Yeah.
12.2, you are working with 12.2 in your device. Okay,
Yeah, so
thank you.
when I flashed the Jetson, the Ubuntu image came out of the box with this. So if I do apt list, this is the CUDA version. I flashed it multiple times because I started installing and trying to change the driver, installing the driver from directly, and then the CUDA, and I messed everything up, and then I flashed it back, and I
Yeah,
left
yeah,
it like the Jetpack 6 is the latest version. So Jetpack is kind of like the whole package, the operating system and the drivers and everything, at least for
yeah.
Jetson.
That's cool. Yeah,
So I out of the box, and if you have a Jetson, I'm putting things in. This is information that is online, but at least I'm putting like the steps that I'm doing for this. So for Docker, these are the steps to install Docker. And here I explained last week of how to modify what I was showing, but with the thing that was missing was every time that I needed to run Docker, I had to include dash runtime GPU all. So what I was trying to show was now that I do you can set the, regardless, like for Kubernetes, even for Kubernetes or kind, set the default runtime in this file to NVIDIA, and then you don't have to specify the dash GPU all and the runtime. So if I do a cat here, see. See, I set this in. So now I can run a Docker image by itself. So if I go to CUDA here, I think I put in Jetson containers. Here it is. So I can run I'll go follow the instructions because people follow instructions. Um, so in here, if I want to run CUDA, see, this is the dependencies, right? Dependents. I think this is CUDA depends on build essentials. And all these things depend on this image. So it's very interesting. But at the end of the day, is this auto tag. trick that they install. So I did the JSON install. So if I run AutoTag CUDA, it would inspect my system. I don't know if people can see this, so I make it bigger. Can you see it better or not? Is that
It's
better?
better. Yeah, now it's better.
Yeah. So check this out. If I do auto tag CUDA, the little script that he has that I installed with JSON containers will figure out what is the image that I need to use. So it gave me back, you need to use based on what it found, right? So it found that the JSON pack that I have is 6.0. It found that the CUDA version that I have in this host operating system is 12.2. And the L4T version that I have installed is 36.3. So this is flashed into the module, and then it was finding what would be compatible. So and then it found that this is the stack image, and this is what I was struggling. I wasted a lot of time like trying to figure out which image to use. So this thing gave me back, you have to use the Nvidia, and this is from Nvidia, right? 12.15.1, the one that I need to use. But if I want to use the one with the examples, he has a repo with examples, then I can do that one. So let me go back to the example. So he has, I can run that one, but there's, I don't know what I'll be doing there. Like there's no, maybe run something, a program that I have compiled with CUDA. Maybe I can do the GPU burn. But if I run this one, which is basically I can provide auto tag or I can just provide the image. If I run this one, then I can be able to run like the examples inside of it. And the examples are a couple of examples on that repo that I was showing that I'm using device query. So let's do that one. So if I go back in here and I run Docker, let me see, Docker, I'll run this one. Wait, I'll run, let me see, which one should I be running? I can run this one and you will see what it happens. Like, so if I run this one, see, it will figure out what are the extra flags that it needs to do. So it also does the devices, it mapped the devices inside. So it went very fast. And this image is 9 gigs, by the way. So I had problems downloading into Kind, like the pod timeout. So I had to load it. But basically, it runs network host by default. That's a nice thing to have. It mounts the Jetson socket, so now I can run the JTOP, inside the image. But at the end of the day, what I need to do here is if I go to bin/arc/linux/releases, and I run the same device query that I was running on my host, this one will work. And I couldn't get this working with like my try and error of things. So now you can run like any CUDA things inside of it, even PyTorch. So if we want to try PyTorch, we can do PyTorch. Where is PyTorch? Let me see what we're doing. I'll skip PyTorch to jump into Kubernetes. So this is how far I got.
Could I'm sorry. Could I interject? So I remember how much trouble you were having with this last week.
Yeah.
And how did you find the GitHub repository? Was it part of the package, or was it just you stumbled upon it?
I read the wiki of the the Jetson provides you, when you install it, provide you different wikis and forums, and I went searching online, searching on Google until I found I think that one of the wikis was that I have in here for Jetson setup. I think it was one of these. Let me see which one it was. I think it was the wiki that I was using for flashing this thing. You remember I was showing this last week?
Yeah.
And one of the instructions was this thing. I think it was Red Computer. No, it was one of the instructions in here. Maybe it was applications, vision. They have a bunch of applications that you can run, but all of them point you back to the JSON container thing. I think it was. Some of them do, some of them don't. But one of them I was able to find it. But once I found it, like
Oh
maybe
yeah,
that
so
was the.
I looked at it. The repository is run by an Nvidia employee, and so it's just this guy named Justin or
I don't
Justin.
know. Maybe Shun Wu know him.
No. You should give him a star.
Yeah. I think I already did. If I didn't do it,
Give him a star because
yeah,
it's just
yeah,
an Nvidia employee, and if he didn't put that out there, none of this stuff would work. I thought it was excellent that you found that because
yeah. It's not under
I was
Nvidia,
yeah,
so
because it didn't seem like something that the greater open source community would be supplying. And I thought, wow, someone must be really busy in the open source community to generate all this.
yeah,
And
all
go,
this stuff.
no, he's an NVIDIA employee.
Yep. So let me show you
Okay.
So last week I was trying to run Olama or Llama, like in Spanish it's called Llama. Olama, and it wasn't working. Remember, was using CPU, and I want to use my GPU. So the trick was here. I went to packages, Ola, and then I was searching into the Olama repo, GitHub repo, to look like how people are doing Jetson. They claim that Jetson 5 works out of the box with the binary, but it didn't. So I went to the Olama one. And here will be under LLMs. Olama, where is it? Olama, and he has the image. So he has the image to run Olama. Like boom, it works out of the box. But I wanted to know like why the Olama that I downloaded and even compiled didn't work. So the reason is because this Docker file, when you run it, they do some magic replacement of the source code. So they go inside and run this utility to find nproc gen common.sh. So actually they're git cloning Olama, and then they do the go build. So they're doing this extra stuff, this gen, installing this gen and replacing something in the gen.com.sh. So somehow that's the hack that you have to do to generate the files, if that makes sense. Like they run this and they replace this J8 for the J. I think these are the processes. What was the other thing that they remove? They did something else, and then compile it. Was trying to figure out the other day what was the thing. Then bash gen linux.sh, and then they compile it. So somehow they are able to compile it, and it worked. So let's give it a try. So if I go to Olama, now I should be able to run, for example, like this with the JSON container. Oh, I'm inside this, still in the other one. Let me close this. Let me clean this. Oh, so the way I was running it was to remember I was showing like to validate that it's actually using the GPU. I'm using JTOP to make sure that the GPU is like being exercised. So in here, let me exit from here. Do I have things running? I only have kind work running, but I can run it. I can run this. And as you can notice, one of the things that you can look in Olama is if it's using CPU or GPU, and that's available here somewhere. Let me see if it's here. Maybe it didn't print. I think it prints in the logs, not here. So for example, if I do cat, it will say that it's using it's cut off. I think it's because it's cut off. See that it's saying like I can run CPU or I can run CUDA v12, and then it is selected. If you notice here, it says selected library CUDA. So it would be using the GPU. I was playing with kind, and there's hacks that I found today, but I didn't get it running by time. But next week I'll show it what are the hacks that you have to do, or the things you have to do to make um, the containers or the pods that you run in kind see the GPU and use CUDA. I didn't get far enough, but at least now I'm far enough that Docker on this machine, Containerd on this machine, without using Kubernetes, or if I use kubeadms, if I run Kubernetes by itself, not through kind, it will work. It will work, but I didn't do that part. But this is how far I got. So it's able to detect the driver, even the name of the GPU, name of the module. So it's a ring, the driver, CUDA. So everything works there. So let's do something fun, right? So let's run Olama something. So I can run Olama run Mistral, or I can run Olama Llama 3, which is the latest one that came out. So that one, I think I have the name somewhere, is this one, Olama Llama 3 Grok Tools use AB. So we can use that one. We had it, this one. And then if I do Olama run this guy, and notice that when I run this from Jetson, or I run it from Docker, it's mounting the slash data folder. Where is it? It's mounting this volume home, my home directory, C Santana, Jetson container slash data to slash data. So when it downloads the model, it downloads it in the host. So if I run it again and again, I don't have to download the model into the ephemeral Docker container space or the Kubernetes ephemeral space. So that's why it loaded so fast. But they're big. So and then we can add something. And see if the GPU will go fast. So what would be a difficult thing that we can do that will take some while? So I was asking things like generate a Terraform file to create a Amazon, because this is the things that I do, right? At work, Amazon EKS cluster. I think somebody said with Carpenter, we'll leave it like that, including a VPC, right? And then it started like faster than the Raspberry Pi, right? Super. If we remember, we did it in Raspberry Pi with CPU. It was taking forever, and you can notice on the right that the GPU now is 99.8%. My CPUs, my ACPUs are like nothing, right? It's not using the CPU, it's using just the GPU, and I'm still going. So that made me very happy. I got this working like 2 days ago.
Congratulations. It doesn't look easy. In fact, it looks hard. All the work you had to do?
Yeah, as long as you can find another person that have like notes and things to do, then it's easy. But yeah, it's everywhere. I found information in the forums. I found information in the wiki. I myself, like, the parts of Docker and Kubernetes, that part I have covered. But yeah, the specific things about the CUDA and the driver and the Jetson is different from the regular Nvidia GPUs. That's the part that I'm learning. But yeah, this is running, and notice that the Docker containers was executed with host network. That means that the Olama server is running on this port in 11434. So now I can run like a Python script that I'm using LangChain, like Nimpandra was using LangChain, that connects to a host that has a LLM. Now you can use the Olama endpoint to do anything that you want. For example, we can even use curl. Let me see if I have a curl command here, example. If not, we can take one from, this one, for example. We can now do a curl against that endpoint. In this case, I was doing it with a Knative to like scale from 0, but we can put in here HTTP localhost, I guess, 11434. And then it's the same prompt, and I can run it from here. It gets low a little bit. I don't know what's running behind the scene. Oh wait, I think I had a typo here. HTTPs. And then run it there. So it's available now. See? So now if I have a whatever of library that I find online to do machine learning, AI, Gen AI, and I need to hit a LLM, now I can hit the LLM sitting in my Nvidia Jetson in my desk, and I can run it from my laptop now, access that IP address, and then do it from my laptop. And the next thing that I can do is they have a nice GUI. Well, there's a bunch of GUIs. I can run a GUI against that port. So, for example, he even has the command in here. Where is it? I think it's called the web UI thing. This one, the web UI, open web UI. And it's kind of an interface to chat with the model. So let's run it. So I'm going to run it on network host, but I'm going to map the host gateway to host docker.internal, and this is how you can access the host, like whatever is running in my host from inside a container. So this is a kind of trick of Docker, and then run the image. So let's run it in another terminal, and let's get a GUI up and running. So we're going to
So
run it.
Open Web UI, I use that with Llama 3. So this is familiar. This is good that you can get this working. This is really good.
Yeah. So in your case, you were running on a machine without a Nvidia GPU or CUDA, right? So you were using CPU,
Right.
the model. So that,
Right. And it's just a couple tokens a second.
yeah.
Dum.
So in this case, I was running both in Knative, like from scale to zero, and connecting them in Kubernetes. But it was using CPU. When I get it running on GPU, then I will show it. Maybe I'll show it next week. But in this case, I got it's baby steps, right? Step one was like configuring Linux and getting it working on the host. Step two, get it working on a container runtime, Docker or container D, which is this piece. And the next week, maybe next week, I'll show how to get it running on Kubernetes. But I will show a little bit about the storage, because today we were going to talk about databases and storage. So it's the same concept, PV and PVC. So this thing should be working now, and I should be able to hit since I'm running on network host, it should be on localhost 3000, I think is the thing, or 8080. I think 8080. You can map it to 3000, but I think it's 8080. So let's give it a try. Maybe I will run it I'll run it here. What is my HTTP 192.8080? That's not the IP address of my thing. Let me see if I can run it. It says 8080. What is the IP address of my thing? Oh, wait, I could do a port forward. Here we go. Let me open it here. Let's see if it opens. So this one will go through the VS Code. Let me see if it's localhost 8080. Should go through this is a way you can do like VS Code port forward connected to an SSH. And it's just detected that 8080 was there. So if it's not running, it did health. Somebody did a health. I don't know why it's not loading. Let me see if, and it's because I'm in my Mac and that Linux is over there. It's running on the host. So it's definitely there. If I curl in here, it's there. It's not IPA. IPA, not the beer. Grep 192. Oh, 114. So let's go to the IP address and 8080. There you go.
There you go.
So, and then you create a new account. I think you have to create a fake account with Carlos at amazon.com. Something. I think you can put whatever you want in here. And then you're in. Boom. And then the question is on the select model will show the models that already have in that data folder. And it is, because I have played with Tiny Llama 3, and then the Grok
There you go.
ones. So I can start having a conversation and saying like, create me a Python script to what else? What could we add that would be very complex? Create me a I don't know, a Python.
Well, even tell me a joke would be because I remember how
Yeah,
slow that was.
tell me a joke about engineers, right?
Yep.
Let's see what it comes with. I don't know if it's that, if it gives me the information. There you go. In the Raspberry Pi, remember, was it took a while. Can you? I don't know if it translate. Engineers gone wrong. Oh, you can give it a title to this thing. Interesting. I
Why
don't know.
did the engineer cross the road? Because she wanted to test her bridge theory.
You see, create a script to deploy a container on Jetson, Nvidia Jetson. Let me see if it does it correctly. It says pull the Docker image. Yeah, very generic thing. Didn't give me the answer. Give me runtime says Jetson, which is wrong. Yeah, but yeah, that's basically you're using machine models in your computer. So
So Carlos, do you have a computer at home with a spare PCI slot where you could
no,
plug a 4090 in?
no,
I
I
don't
don't.
either. I don't either. So
That's
this
why
is
I got.
this
That's why I got this small device.
right. So this is so you could either go out and get a gaming PC and
Yep,
upgrade it to a 4090, from
yep,
if you're Micro Center or wherever you go to get big gaming PCs
yep,
and put a 4090 in it, or you can get a little Jetson box for a lot less money and run a GPU that way.
yep. Yeah,
Yeah,
yeah.
but
And the thing is, it's for development. Like these Jetson devices are for like development. They're called development kits that Nvidia
No,
puts out, and it's for doing the research, trying things, not at scale, right? And then they would use the Jetson either a scale. I'm using it for like trying things in here locally. Maybe I want to do things that I don't want to put publicly anywhere, or I don't want to use a public API, right? Everything private. um, or just like try to figure out all these and just learning purposes, right? Learning about Nvidia GPUs and learning how they work and how the drivers and the containers and everything, and then I can use it on the cloud, which is a little bit easier, and there's more help on the cloud. Like we my team also have like a bunch of GitHubs, Argo CD, Terraform, everything that do in ECAS to do machine learning. But I just wanted to learn from the ground up this thing. So let's play with a little bit with Kubernetes. So we have a few minutes. So one thing that I did was I was able to, last week I was playing with Knative, and one thing that I figured out is that in Knative, I needed that folder. If you notice, this folder that I have in my home directory, Jetson data, it has the models. So the model is here, the Olama model is here, Whisper, all these things are there, and they consume a lot of space. So I wanted to add it. I can do, if I run Kubernetes bare in here, I can just use a host path against this and it would work. So for example, I will create a PVC like this. So you will create a persistent volume claim. You will use you create persistent volume first, right? And you will point to a path. If you're running Kubernetes like in this host and it's matching that folder. In my case, I really like to use kind for Kubernetes because I can switch the version of Kubernetes. I can delete and destroy. I can mess around. So I really love kind in terms of experiments and running Kubernetes. So for that, kind runs in Docker. So the PV cannot point to this folder because this folder doesn't exist in the Docker where kind is running. It exists on the Linux OS. So I need to do like a double mount or double path, double mount thing. So what I need to do is mount this folder that is in my host /data home directory Carlos into the kind cluster, and then once it's in the kind cluster in a directory, then I'll point it here. So the way you do that is in kind, I find out is through this. So if you create a kind.yaml, basically you can create a kind cluster and do extra mounts. Like I want to mount my home directory where all the models are taking a lot of space are located. The container path inside the kind cluster will be this. So this is the location where like the files are in my PV and PVC. And then this is the second one that I was trying out on how to make the Nvidia devices available in here is through here, but you have to like change something in the tom.ml. So I show this next week, but the important part is this. So you create a cluster, basically, let me see if I have a cluster, get clusters. Already created the cluster. So I went ahead and did kind create name knative -- config, and then that thing, and it came up. So I should have k get pods, bunch of them. I did the source. I like to use, let's see, k get pods -a. So that's it. I was playing with knative, and then I can do kn quick start on top of it, and it will ask me if I want to destroy kind and create a new kind, and say like, please do not destroy, use the same thing, and it will install knative on top of it. And what I'm trying to do is I want to create a Kubernetes pod that spins up on demand when I hit the URL of Oyama and run the Oyama pod on demand. And then if I'm not using Oyama, then it goes to 0, it gets destroyed. And then I want to also run the UI the same way. If I hit the API of the UI, the pod will run, and when I stop using it, the pod will die. So in Knative, you would create a pod definition like this, and basically you put like you want to run this is the key that we were looking like. What container can I use on ARM64 on Jetson that works Olama? It's this one. I want to run Olama serve. I want to be the container port. I need to specify the container port because of the liveness and readiness ports. It checks in here. And then I want to mount /data from a PVC, and that PVC is this one. So those ones I'll be creating here. I'll create the PV that is this is the folder. You have to put storage class something manual so it doesn't take the default one. Write once, run many really doesn't matter because it's a folder, but you can say write once. I only have one node. And then a persistent volume claim, that is the one that I'm going to specify in the pod to mount to that data folder. And the storage, it really doesn't matter because it's like host path. So yeah, this is done. So it's running. So the next thing you have to do is enable 2 features in Knative that don't come by default is allow the use of volume claims, allow to write into these volume claims. If not, you will get an error. So let's do that. So let's do this. And then this is the same process you would do for which folder I am. where is this folder? Okay, yes, I moved this thing because I wanted to. Yeah, I put that, and then I will deploy the PV and the PVC, which is this guy, right? With the host path. I can check PV and PVC to make sure they're like bounded. So that's something like there's no errors, right? The PVC is pending, but it should be bounded, I think, if it's correct. I don't know why it says binding. Let me see. Maybe because it's host. I think I ran out of time. And then if you deploy something like this, then it will start the pod, for example, and mount to it. Let me run it again. Where is it? Oh, I don't have it. So yeah, k apply -f olama dot YAML, and it's created. So the pod is running and it's mounted. Yeah, it worked. K describe pod olama. Oh, I was asking for a GPU because I was playing to make it work. This is why I added this. But for this, I need the operator to tag the node with a label that will tell it that the Nvidia GPU is there. So we'll leave it at that, and so we'll show it next week on using a GPU from Kubernetes. The normal way that you
I think this is great.
running on the cloud.
Carlos, I think this is great. You do this and you do Volcano in 1 week.
Yes.
So is this like your day job? This is like a full-time job. Just
No, a little bit of researching and trying things. No, my real job is a meeting that I have to go to talk to enterprise end users of using Amazon EKS in production.
oh, that's your day job. Don't forget your day job. This is amazing. This is amazing.
Yeah, this
I'd
is
be
just
interested to
fun
see
to
what you
get
come
with
up
other
next
people
week.
to talk
Oh,
about
yeah.
Kubernetes. Yeah.
And the adding the dimension of Knative interests me. Olama by itself is designed to just sort of go to sleep if it's not hasn't been used for 30 minutes. If
Yeah,
Knative is a
that's the
better way
value
of
add.
doing
If
that,
not, then yeah,
yeah.
it's a pod. A pod is a pod. But I didn't want to mess with the service and an ingress and the IP address, and like it was easier just to do it this way.
Okay.
Okay, very good. Thank you.
Okay, we'll see you next
Yeah,
week.
thank you.
Thank you, folks, for
Thank you.
joining.
Are you going to do another webinar on Thursday, next Thursday?
No. So yeah, Thursday will be another CNCF ambassador.
Okay,
Friday
I'm
I'll
gonna
be here.
I'm gonna try to
Yeah.
dial into that if I'm available. I'll try to dial
Yeah, I don't know
into.
what will be the topic, but it'll be a CNCF project. Yep.
Very
Okay.
good. Very good. Thank
See you,
you.
folks.
See you.
Thank you for
Bye.
joining. Thank you,
See
Chunwin,
you.
for
See you.
joining.
Bye.
Take care. Bye bye.